Hey everybody, we are going to look at an example of integration by parts. So we're multiplying two functions together and integrating that. And in this case, the two functions we're integrating are going to be a exponential function times a trig function. And if you remember when we were doing parts, we wanted u to be a function that when I took its derivative, this new integral over here became a simpler integral, an easier integral to work with. Well, if you think about it, the derivative of e is e. It's going to be e to the 2x times 2. So if we made that, it's not any simpler. It's 2e to the 2x. All right. If we made cosine, if we use that as our u, the derivative of cosine is negative sine. And that's no better than, the v prime would be the e one. And it's not going to be really any different than it is now. The only difference is going to be the appearance, because the derivative and antiderivative of cosine will involve sine in some way. But it'll still be an exponential times either a sine or a cosine. So the new integrand is not any better than the old integrand. And no matter how many times we do that, we'll always have e in either sine or cosine. Okay, and it may sound like this is a lost cause that will never get any better, but I want to show you what happens when we do this. All right, so let's do this first run of it. I'm going to let u, I'll call it u1. We are going to have to do this multiple times. I'm going to let u1 be, I'll do the cosine function. Cosine 5x. And I'll let v prime, this first run, v prime 1, be the e to the 2x. Alright, now I could have easily switched these around. There's really no better option for u, for e versus cosine in this case. Now, u prime 1 is going to be, the derivative of this would be negative sine 5x times 5. Alright, so that'll make that I'm going to have to do the chain rule. So that'll make a negative 5 out front. Okay, and then v would be the antiderivative of this. Well, because of that 2, I would have a 1/2 e to the 2x. Okay. Now I'm ready to do this. Okay, uv, that's these two. So I have a 1/2 e to the 2x cosine of 5x. All right, and then minus u prime v minus this times this. Notice there's already a minus here. So minus, and then this will be a negative. That'll actually make that a plus. And then the integral of u prime v. I'm going to stick this 5 and this 1/2 outside of the integral. And then I'll write it as the 5 and the 1/2 and the negative are all outside the integral. So it'll just be e to the 2x sine of 5x. So e to the 2x times the sine of 5x dx. So there is my new integral. But again, if you kind of analyze it, this had an exponential times a cosine. This has that same exact exponential times a sine. And remember, a sine and cosine, if you think about their graphs, they're just the same thing, just shifted. So literally this and this are basically the same thing. There's hardly any difference at all other than just a shifting effect. So these two graphs are virtually the same of the integrands. So it's basically like I didn't improve this new integrand at all. All right, well, if I did it again, if I ran this one more time, I have to stick with you. You're not going to switch. You're not going to say, all right, well, I did u as the trig function this time and v prime as exponential. Oh, I'll switch it to u being the exponential. You don't want to do that. You want to stay consistent. So I let u the first time be the trig function. So I'm going to let u stay the trig function. So in this part right here, our new integrand, I'm going to let u be the sine function. And I'm going to let v prime be the exponential again. Now since that's the exact same thing I let it be the first time, I know what v is going to be. It's once again to be 1/2 e to the 2x, because that's what it was the first time. That's not going to change. Alright, and my new u prime is just going to be positive cosine 5x times the 5. So I got to chain on that 5 out front. So 5 cosine 5x. Alright, and now I'm ready to expand this part. Now this part right here is being multiplied by 5/2. I'm going to keep that 5/2 out there and distribute it through in just a little bit. Alright, so I'm going to keep all of this that I had to begin with. Alright, now inside of this, we're all the way up to where the yellow started at the 5/2. We're going to replace this with integration by parts. We're going to replace it with, again, uv, so the 1/2 e to the 2x sine of 5x, and then minus u prime v, so minus 5/2 e to the 2x cosine 5x. We're going to put that in our new integral. So minus, again, I'm going to pull the 5/2 out. So minus 5/2. Now the new integral is u prime v, so the 5/2 is already out, e to the 2x cosine 5x. So all this stuff is replacing the stuff that's in yellow. That's just expanding this. There's the 5/2, and this is parts on that thing. Okay, remember that we're saying they're equivalent, so that would be parts on that most recent integral. Now, if you look at it, you may be thinking, well, alright, e to the 2x cosine 5x, it's not any different. It just keeps staying the same. The new integrand is the same setup. It's always exponential and a sine or a cosine, and it's just going to keep being that way. And that's true. But here's the kicker. Not only is it an exponential and a trig function, it's exactly now what it was to begin with. Alright, and so what we're going to do now is it's basically like algebra. If I had something like x is equal to 7 minus 3x, I could group the x's together and I can solve for that x. It's just now this x, this unknown, is like this integral. When I finally distribute these 5/2 through all of these pieces, I will have an integrand, an actual indefinite integral in two different places inside an equation, and I will just be able to do the same thing as with algebra. I'll be able to solve for the integral. So that's how we have to handle it when we have an exponential times a sine or a cosine. Alright, so I'm going to distribute this 5/2 through, and then that will allow me to move this thing around to join the original. So on the next line, so there's a 5 times 1 is 5, 2 times 2 is 4, so 5/4. 5 times 5 is 25, 2 times 2 is 4. Alright, so there's the new thing. And now what I'm going to do, the last thing I'm going to do is just algebra. I'm going to add this, all of this, to this because they are the same. They have the same integral. And again, these things are equal. Okay, so I'm going to add this to both sides of this equation. There's 1 here. There's 25/4 here. So when I add them together, I'll have 29/4, right? I'll have 4/4 plus 25/4 is 29/4. Alright, so I added this 1 integral of e to the 2x cosine 5x to this 25/4 e to the 2x cosine 5x. I'm adding when I move it over here to join this. So that again, that'll make a 29 e to the 2x cosine 5x. And it equals this line right here with this gone. So it equals these two pieces. So the 1/2 e to the 2x cosine 5x plus 5/4 e to the 2x sine 5x. And then what's the last thing I need to do? I need to multiply both sides of this equation by 4/29 on this side and times 4/29 on this side. And when I do that, I can distribute this through, or I can just hold it out front, put the parentheses around it. I just got to remember to put the plus c on the end. So I'm going to multiply both sides by 4/29 to get this isolated and back to the way we started. So if I multiply by 4/29 on the left-hand side, so there's our 4/29 times this stuff. I've added the plus c now since we've isolated this. All right, now simplifying, I'm going to pull out, there's an e to the 2x in both of these. All right, and then we talked about in class, the 4 is the bigger denominator. So if I pull out a 1/4 and an e to the 2x, the 1/4 would cancel with this 4 here, the 4 on the bottom, and that would leave me with a 1. There's an e to the 2x. So I have an e to the 2x over this 29. All right, and then again, the reason why I'm pulling out the 1/4 instead of the 1/2, even though 1/2 is technically bigger, 1/4, if I divide a half by 1/4, I get 2. So it's a whole number. That'll make whole numbers in both these places. So I have 2 cosine 5x. All right, and then over here, if I pulled an e to the 2x and a 1/4 out, I'd have 5 sine of 5x. All right, and then I have that plus c. And again, you can distribute this through and see you get right back to what we had before. All right, so there is integration by parts with an exponential and a sine or a cosine. If you look, this would be the same thing that we would get from the table. The 4 there is coming from the 2 on e to the 2x squared. All right, and then the 29, that is the a squared, the 2 squared plus the 5 squared. 2 squared is 4, 5 squared is 25, 4 and 25 adds to 29. All right, and then you can go through and see that you'd get the same thing if you use the table. But that's where the formula is coming from. It's coming from integration by parts. A couple of times, there'll be a sign change the next time we get back to the cosine. So it'll be a negative. We add it to this, and that gets a way to solve for that integral. So you have to do like algebra within your calculus to solve for this thing when you have an exponential times a sine or a cosine.